Okay, let's talk about 5-5 roots of real numbers. So there at the top it says if a squared equals b, then a is the square root of b. And that's what we've known for a long time. If I take the square root of a squared, I get just the square root of b. Then it says taking the nth root and raising a number to the nth power are inverses. Remember, an inverse means it undoes it. So if a to the n equals b, then a is the nth root of b. Okay, now we need some vocabulary. When I'm taking roots, the number right there, we call that the index. The guy under the radical, we call the radicand. So some things happen when my indexes are odd or even and my radicand is positive or negative. So this chart right here talks about what happens when my radicand or my index is even or odd, and what if my radicand is positive, or my radicand is negative, or my radicand is 0. Alright, so if I have an even index, 2, 4, 6, 8, anything like that, and the guy under the radicand is positive, I get one positive root and one negative root. Think about 16. When I take the square root of 16, two numbers that are exactly the same that multiply to give you 16 are both positive 4 or both negative 4. So I get one root that's positive and one root that's negative. Now, if my radicand is even and my index is negative, the square root of negative 16, that's no real roots. That's not possible. I don't have two numbers that are exactly the same to multiply to give me any negative number. So I get no real roots. If my index is odd and my radicand is positive, I get one positive root and no negative roots. There's no way for me to multiply 3 negative numbers together or 5 negative numbers together and get a negative answer. Okay? I mean a positive one. If my index is odd and my radicand is negative, I get no positive roots and one negative root. If my radicand is 0, my answer then will always be 0. Okay, so look at 16 here. There's no number in the index. When there's no number in the index, we assume him to be a 2. So really what I'm trying to do is I'm trying to get all of those to have an exponent of 2 so that it undoes it. Okay, well I could do that. I could say 4 squared is 16 and x to the third power squared is 6. Remember, if I take the square root, I'm undoing the nth power, or I'm undoing the nth power with the root. So this guy, the index and the powers undo each other, so I'm left with 4x to the third. Essentially, if you look at it, what did we do? We took the square root of 16, that's 4, and I took my exponent of 6 and I divided it by 2. It's essentially what you're doing. Okay, so look at number 2. My index is 2. I have a negative out front, so it doesn't affect my radicand at all, so I'm going to keep it out there. And I have an exponent of 4. Again, you could think about that guy as written like this. Do you have to do it this way? No. So that exponent, or that index, will undo that exponent, and I'm left with a negative q cubed plus 5 squared. Again, I took my exponent, I divided it by my index. For the next one, I'm going to use a power chart, and I've given you a power chart, or I will give you a power chart, and we will fill them out together. You can use this power chart on your test. You can use it while you're working on your homework. Keep it handy with you. So I have this handy dandy power chart here. And this guy has an index of 5. So I'm looking for the fifth root of 243. Okay, so I go down my powers of 5, 243 there. The fifth root is 3. So 3 to the fifth is 243. A squared to the fifth is a to the 10th. And b cubed to the fifth is b to the 15th. So I'm taking the fifth root of 243 and I get 3. 10 divided by 5 is 2, so a squared. 15 divided by 5 is 3. So I get 3, a squared, b cubed. Alright, number 4 test says take this square root, my index is 2, of negative 4. Alright, this says if I have an even index and a negative radicand, I get no real roots. Even index, negative radicand. Okay, well, what about 5 here, though? It says say, take the seventh root of 128, negative 128. That one's okay because I have an odd index. I get no positive roots, but one negative root. So I'm going to end up with a negative answer. The seventh root of 128. The seventh root of 128 is 2, but it also told me I'm going to get a negative. So this guy is essentially the seventh root of negative 2 to the 7th. So that guy's negative 2. Alright, number 6, the fifth root of 243. We just decided that was 3. Again, you can look at your chart if you want. And essentially, like I said, you're taking your exponent, dividing it by your index. X squared to the third. 15 divided by 5 is 3. Alright, number 7 and number 8 say approximate with your calculator the fifth root of 891. Use 3 decimal places. Okay, so we're going to use our calculator and I'm going to show you how to put the fifth root of 891 in there. Now, use 3 decimal places. That means round correctly. Alright, so I want the fifth root, so I'm going to push 5. And then I'm going to hit the math button. It's below the green alpha button. And I'm going to scroll down here to number 5. It has x root. That means I'm putting my 5 in as my index. Some of you will see it make that 5 smaller. Some of you will just keep the 5 out front with the x in front of it. 891 to 3 decimal places. That means I'm going to look at the fourth one. It's a 2. That means I'm going to keep it. So 3.890. The next one, I have a negative out front. I'm going to just keep that negative and write it down. But in my calculator, I'm going to put 3 math. Don't put the negative in your index. So I just want the third root of 19. Six, 6, 8, 4. The 4 tells me, remember, if it's 4 and below, keep it, stay down low. 5 and above, give it a shove. So that would be negative 2.668. If you're not sure about rounding, you can tell your calculator to always give you 3 decimal places. So if you hit the mode button and see where it says float right there, you can change it to tell you to always give you a certain amount of decimal places. So I can put it on 3, and it will always give me 3 decimal places. So if I push enter again, 2.668. So remember to round correctly there. Alright, that was 5-5, roots of real numbers.